So on this example, we are looking at finding f at 3, f at negative 1, and f of a. And then we're going to find f of a plus h. So all we need to do is plug in these values wherever we find x. So to find f at 3, this will be negative 5 times 3 plus 1. This will equal negative 15 plus 1, which will equal 14. So all we did was plug in 3 wherever the x was, and then we did our math. So then to find f at negative 1, we're going to get negative 5 times negative 1 plus 1, which equals 5, plus 1, which equals 6. Now we're going to find f at a. And to find f at a, we're just going to plug in a wherever the x is in our original. So f at a equals negative 5 times a plus 1, which will equal negative 5a plus 1. Now we need to find f at a plus 3. So for f at a plus 3, negative 5 times a plus 3 plus 1, which equals negative 5a minus 15 plus 1, which is negative 5a minus 14. Now, if we have a more complicated example, then we can, we have to do a little bit more math with it. So if we look at example 12 on our review, we have f at x equals 3x squared minus 6x plus 3. So on this, we're going to use the same values, and we're going to plug them in here. So for our first one, we will have f at 3. So this is 3 times 3 squared minus 6 times 3 plus 3. So 3 times 9 minus 18 plus 3, which gets us 27, minus 15, which will get us to 12. Now, if we do f at negative 1, so f at negative 1 equals 3 times negative 1 squared minus 6 times negative 1 plus 3. This will get us 3 times 1, because whenever we square a negative, we always get a positive, plus 6 plus 3, which gets us 3 plus 9, which again, just by coincidence, will get us to 12. Now, we need to find f at a. So for f at a, we're going to get 3a squared minus 6a plus 3. And that will be all that we have on that one. Now we need to find f at a plus 3. So if we want to find f at a plus 3, we are going to need to plug in the a plus 3 into all of our squared terms. So we're going to move this one down this way so we have a little bit more room to work. So this will get us 3 times a plus 3 squared minus 6 times a plus 3 plus 3. So we're using the same process that we did on the previous, except we have to square our a plus 3. So this will get us 3 times a plus 3 times a plus 3, because when we have a plus 3 squared, it means we have a plus 3 times a plus 3, minus 6a minus 18 plus 3. So 3 times a squared plus 3a plus 9 minus 6a, and this one is minus 15. So now we'll combine our like terms here. So we get 3 times a squared plus 6a plus 9 minus 6a minus 15. So this gets us 3a squared plus 18a plus 27 after we distribute our 3 minus 6a minus 15. Combining all of our like terms, we get 3a squared. 18a minus 6a will get us 12a. 27 minus 15 will get us to 12. So that would be our final answer on the f of a plus 3. So using the same process, we can use this to find the f of a plus h minus f of a over h. So that's going to look like this. So if we want to find f at a plus h minus f at a all over h. So with this, we can use what we've already found on our previous problems to locate this. So what we need is the f of a plus h and f of a. Well, we have found our f of a in this case, using this example. We have our f of a is equal to 3a squared minus 6a plus 3. And our f of a plus h, we would still need to locate. So, because in this case we did a plus 3. So let's take our same function and let's find f of a plus h. So we're going to use the same function here. So we have 3x squared. Let's find it right here. So we're going to find f at a plus h will be equal to 3 times a plus h squared minus 6 times a plus h plus 3. So this will get us 3. Again, this would be a plus h times a plus h. That will get us a squared plus 2ah plus h squared, then minus 6a minus 6h plus 3. Sorry, I ran out slightly, a little bit of room there. So this will get us 3a squared plus 6ah plus 3h squared minus 6a minus 6h plus 3. We're going to take this part right here. We're going to take each of those parts and we're going to plug them in. So we're going to take this part right here and this part right here, and we're going to plug it into our function. So this will be the f of a plus h, so 3a squared plus 6ah plus 3h squared minus 6a minus 6h plus 3, and then we'll subtract what we have up here for our f of a. So 3a squared minus 6a plus 3. All of this is over h. So now we will have 3a squared plus 6ah plus 3h squared minus 6a minus 6h plus 3 minus 3a squared plus 6a minus 3 all over h. If we did it correctly, then everything that does not have an h will cancel. So 3a squared minus 3a squared, and then we'll have 6a and negative 6a, they cancel, and the 3's will cancel. The only thing we have left are terms that include an h. So here we will have 6ah plus 3h squared minus 6h. So that's all the terms that we have left because the others are canceled out. This will be all over h. So now we'll factor out an h on the top. I'll leave this with 6a plus 3h minus 6 all over h. Now the reason we're only factoring out an h, even though they were all divided by 3, is because when we finish, the h's will go away. We'll end up with just a simple term of 6a plus 3h minus 6. And we want to keep it to where we could plug anything else back into it if we need to. And that's how you'll find f at any term that you need to find.